breaking a carbon-carbon bond in the target molecule to identify simpler starting materials and reagents that, when linked in forward synthesis, will form that bond. Retrosynthetic disconnection for a carbon-carbon bond means imagining cutting that bond in the product to see what two pieces would make it, then working backwards step by step until you reach available starting materials. Think of it like taking apart a toy to see which two pieces fit together so you can rebuild it later. Each cut suggests a reaction that could join the pieces in the forward direction. Chemists choose which bonds to break by looking for reactions that are reliable, give the right connectivity in stereochemistry, and use functional groups that can direct or activate the coupling. Sometimes you pick a disconnection that creates a stable anion or radical intermediate, and sometimes you aim for a bond that can be formed by a well-known coupling reaction or addition. Students often cut bonds without checking whether the suggested forward reaction really exists or is practical, so always verify that a known reaction can form the bond under reasonable conditions. Another common mistake is ignoring how functional groups will affect reactivity and selectivity, so remember to account for protecting groups or activating groups when planning a disconnection. Finally, some try to disconnect into fragments that are not commercially available or are too complex, so prefer simpler, readily available precursors or plan earlier disconnections to reach those. Visit www.gumballdegree.com to find more videos and resources on retrosynthetic disconnection and related organic chemistry topics.